Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. In today's video session, I am going to discuss about the different types of DC generators. Okay, so here basically we are having the two types of the DC generator. One is the self-excited DC generator, another one is separately excited DC generator. Okay, so here in this session, we have to discuss about the different types of the DC generator. So basically we are having the mainly two types. So mainly we are having the two types of the DC generator. So first one is self-excited DC generator. Here is the first one, and second one is separately excited DC generator. Okay, so these are the two types of DC generators, right? So here the first one, self-excited DC generator. So the self-excited DC generator, it is classified into three types. The self-excited DC generator is classified into three types. So in that, first one is series wound DC generator is the first type, and second type is shunt wound DC generator, second type, and third type is compound wound DC generator. Here is the third one, right? So first one is series wound generator, second is shunt wound generator, and third one is the compound wound DC generator. So these three are belongs to self-excited DC generator. Okay, so here again the compound wound DC generator, which is classified into two types. So first one is short shunt compound DC generator. Here is the first one, and second one is long shunt compound DC generator, right? So we are having the mainly two types of the compound wound DC generators. So in that, first one is short shunt compound DC generator, and second one is long shunt compound wound DC generator, right? So here we'll discuss one by one. So now, so the first one is self-excited DC generator. So in that, the first type is series wound DC generator. So first one is series wound DC generator. Okay, so here in the series wound DC generator, so first we are going to draw the series wound DC generator. Okay, so here, so here is, this is the symbol of DC generator, or if it is a motor, here is the symbol of the motor. So this is generator. So in series with armature resistance, in series with series field winding, is connected across the load. So this is load here. So and this is armature resistance, and this is series field resistance, and this is load RL. Now for this generator, we are having the generated EMF is nothing but the voltage developed by this generator is nothing but generated EMF EG. In series with armature resistance is there, and in series with we are having the series field winding is there, and load is connected at this point, at these 2 points. Now across this RL, we are having the voltage, that is terminal voltage VT, or voltage drop across the load is VT, and it is a looking like it is a series circuit. In series circuit, the constant term is I. So current through RA I am taking as a IA. So IA is nothing but armature current. At RSC I am taking current as ISC. So ISC is nothing but series field current, and load is there. Across this across this load, we are taking current as IL. IL is nothing but current through the load resistor, that is load current IL. Okay, so here we are having the generated EMF or generated voltage is EG, and at armature resistance we are having the armature current. At series field winding we are having the resistance as well as the current, that is series field current, across the load resistor we are having the terminal voltage, and through this RL load we are having the current IL, right? Now for this type of generator we have to write the current, voltage and power relations. We have to write the current relation, voltage relation and power relations of series wound DC generator. Okay. So first we have to write the current relations first. So here in this current relation, so here it is the entire circuit is connected as a series. So in series circuit the constant term is current. So therefore the total current I am representing as a IA equal to ISC equal to IL. The total current I equal to IA, that is equal to ISC, that is equal to IL. Here is the current relations of series wound DC generator. Similarly, voltage relation. So what about the voltage relations here? The voltage relation of series wound generator is, so in that we have to apply the KVL here. We have to apply the KVL in this single loop. So in that case I am starting from here. So here plus EG, I am taking the second polarity, that is plus EG minus IARA. So here voltage drop is minus IARA minus voltage drop at RSC. I am taking as a ISC RSC minus, now here we can take IL RL R, directly we can take VT. So here directly I am taking as a VT, that is equal to 0. So here we need to apply the KVL in this single loop, right? So we'll get plus EG minus IARA minus ISC RSC minus VT equal to 0. Now by solving this equation, we'll get generated voltage, that is EG equal to VT plus IARA plus ISC RSC. Now you can see IA and ISC both are same here. So in this equation take IA or ISC as a common term here. So EG equal to VT plus I am taking IA as a common term here. So IA into RA plus RSC. This is the voltage equation of the, or voltage relation of the series wound DC generator. So EG equal to VT plus IA into RA plus RSC. Okay. So current relation and voltage relation. Now what about the power relation? So power developed by the generator. So the power developed by the generator, that is PG, is equal to, I am taking as EG into IA or EG into ISC or EG into IL, because current is constant only. So power developed by the generator is equal to EG into IA, that is equal to EG into ISC, that is equal to EG into IL. Similarly, power from the load. So here power from the load. So PL is equal to, already we know the power equation, V into I square R or V square divided by R. So take any one equation. So here I am taking the P equal to V into I. In the place of V, VT is there, in the place of I, IL is there. So now I am taking as VT into IL. Here is the power relations of given series wound DC generator. Okay. So here for the series wound DC generator, the current relation is I equal to IA equal to ISC equal to IL, current relation, and the voltage relation is EG equal to VT plus IA into RA plus RSC, and the power relation is PG equal to EG into IA, that is equal to EG into ISC that is equal to Eg into IL. Power relation of the generator and power from the load is PL is equal to Vt into IL. Okay. So this is about series wound generator, right? And we are having the second one, shunt wound DC generator. The shunt wound DC generator, this is very important. So shunt wound DC generator. So in this shunt wound DC generator, all the branches are connected in parallel. Okay. So here first of all we need to draw the diagram here. So we are having the armature resistance and generator is there and it is connected in parallel with the shunt field winding. It is connected to the load. Okay. So here this is generator. For this generator, we are having the generated voltage Eg and having the armature resistance Ra, and this is shunt. Shunt means it is a parallel connection. So means RSH. For this shunt field winding, we are having the shunt field resistance RSH and load. So this is load RL. So load is RL, right? Now for this shunt wound generator, we need to give the current directions here. So current through Ra, Ia. Now current towards this node point. From this node point, current is dividing. Now current through RSH is ISH. Current through RL is IL. Similarly, here we are having the voltage drop. It is Vt. Voltage drop across the load is Vt. Vt is nothing but terminal voltage across the load resistor RL, right? So here, so we are having the armature resistance and shunt field resistance and load resistance. These three are connected in parallel in shunt wound DC generator. Okay. So in this shunt wound DC generator also, we need to write the current relation, voltage relation and power relations of the given shunt wound DC generator. Okay, we need to write the relations of current, voltage and power, right? So here first of all, current relation. So what about the current relation here? For this, apply KCL here. Apply KCL at this node point. So KCL states that the algebraic sum of the incoming current is equal to the algebraic sum of the outgoing currents. That is, Ia is the incoming current, is equal to, at this node point, outgoing currents, that is ISH and IL. So algebraic sum of the shunt current plus IL. So Ia is equal to ISH plus IL. Okay, armature current is equal to ISH plus IL, right? Now we need to calculate the ISH, that is shunt current. We need to find out the shunt current ISH. So here the entire circuit, it is a parallel combination. In this parallel combination, voltage is constant. So voltage in this branch and voltage in this branch and voltage in this branch will be same only, because it is a parallel circuit. Now ISH is equal to, so according to Ohm's law, I equal to V by R, same as in the place of ISH is there, ISH is equal to, in the place of V, Vt is there, in the place of R, RSH is there. Okay, so this is the shunt current. ISH is equal to Vt divided by RSH is the shunt current. Okay, so armature current equal to ISH plus IL, shunt current plus load current, and shunt current is calculated by the Vt divided by RSH. So here is the current relations of the given shunt wound DC generator. Okay, So now voltage relation. Now what about the voltage relation? For the voltage relation, we can apply KVL in this loop or we can apply KVL in this loop. So here I am applying the KVL here. So I am starting from this point. So when I am starting from this point, always we need to take the second polarity, that is plus Eg minus IARA. So plus Eg minus IARA minus, so here we can take minus ILRL, or directly we can take the Vt. So I am taking the Vt here. So minus Vt equal to 0. So Eg minus IARA minus Vt equal to 0. Then Eg equal to Vt plus Ia into Ra is the voltage relation of shunt wound DC generator. So Eg equal to Vt plus Ia into Ra is the generated voltage of the given shunt wound DC generator. Okay, and now power relations. So now the power relations, the power from the generator. So power from the generator is equal to Eg into Ia. Power from the generator is Pg equal to Eg into Ia, and power from the load equal to Vt into IL. Okay, so power from the generator is Pg equal to Eg into Ia, and power from the load is nothing but Vt into IL. Okay, so here is the current relation, and this is the voltage relation, and this is the power relations of given shunt wound DC generator. Okay, so this is about the shunt wound DC generator. Okay, so now we'll discuss some problems on this types of generator. So in that case, I am taking the shunt type generator here. I am taking the shunt generator. So here a shunt generator delivers 450 amperes at 230 volts, and the resistance of the shunt field and armature are 50 ohm and 0.032 ohm respectively. So now we need to calculate the generated EMF. Okay, so here the problem is based on the shunt generator. So shunt type generator. So already here they are given the diagram. So generator is there, armature resistance is there, and armature current is there. So at this point the current is dividing, that current is ISH, and here load current is there, that is IL, 450 amperes is there, and this is load RL. Across the load we are having the 230 volts, and here is, and this is armature resistance, and this is shunt field resistance, that is 50 ohm, right? So here first we need to write the given data first. So a shunt generator delivers 450 amperes at 230 volts, means IL is given, IL equal to 450 amperes, and at a terminal voltage Vt equal to 230 volts, and the resistance of the shunt field RSH is equal to 50 ohm, and armature resistance Ra equal to 0.032 ohm. RSH equal to 50 ohm and Ra equal to 0.032 ohm respectively. Now we need to calculate the generated EMF, that is Eg. So what is the equation of Eg? So Eg equal to Vt plus Ia into Ra. So already we know the Vt. So Vt is nothing but terminal voltage, that is 230 volts, and armature resistance is 0.032 ohm. Now we need to calculate the armature current, that is Ia. So from this circuit, from this diagram, the armature current Ia equal to ISH plus IL is the equation. Ia equal to ISH plus IL. So in that, already we are having the load current 450 amperes, but we don't know ISH. So we need to calculate the ISH value. So here ISH equal to Vt divided by RSH. So here Vt 230 divided by RSH is 50, that is equal to 4.6 amperes. ISH is equal to 4.6 amperes, right? Now substitute IL value and ISH value in this equation, we'll get the armature current. So therefore Ia equal to ISH. So what is ISH? 4.6 plus IL 450. So that is equal to, we'll get 454.6 amperes is the armature current, right? Now substitute these all the values in this equation, we'll get generated EMF of the given shunt wound DC generator. So now Eg equal to, so Vt plus IaRa. So that is equal to, so Vt, so what is Vt here? 230 plus Ia, armature current Ia is 454.6 into armature resistance 0.032. Now by calculating this 230 plus 454.6 into 0.032, we'll get 246.54 volts. Here is the generated voltage of the given DC shunt generator. Okay, so here is about the, so some two types of the DC generator. Okay, so here in next class we'll discuss about the compound wound DC generator. Okay, so thank you one and all.